Sandy soil drains water in under 10 minutes. A rainfall that would keep other soils productive for days disappears almost immediately. The particles are the largest of any soil type, which is why water moves straight through without stopping. Nutrients do the same thing. They wash out before plants can absorb them. Most food crops refuse to grow in pure sandy soil for this exact reason. Deserts are not just hot, they are mostly sand, and that is the part that makes them sterile. The exceptions are strawberries and peanuts, which have adapted to drain-fast environments. George Washington Carver spent his career finding crops that could survive in the sandy soils of the American South that cotton had already exhausted. Clay soil contains up to 10 billion individual microorganisms in a single teaspoon. No other soil type comes close. Clay particles are 100 times smaller than sand, which means they pack together so tightly they hold water for weeks. That is both the strength and the problem. Clay absorbs water well, but drains so slowly that plant roots can drown in it. When it dries out, it contracts and cracks hard enough to break tools and damage underground pipes. The Nile Delta, one of the most productive agricultural zones in human history, sits on deep clay deposits left by floods over thousands of years. The same property that drowns plants in wet seasons grows cotton, rice, and wheat in calibrated amounts. Silt sits exactly between sand and clay in every measurable way. The particles are medium-sized, the drainage is moderate, and the fertility is high. Every major ancient civilization built itself on silt. The Mesopotamian Empire sat on deposits from the Tigris and Euphrates. Egypt fed the ancient world from silt left by annual Nile floods. The Yellow River in China carries more silt than any river on Earth, enough to turn the water a color that gave the river its name. Modern flood control systems have largely stopped the annual deposits that made these regions fertile for thousands of years. Several of them are now struggling with declining soil quality for the first time in recorded history. Loam is the only soil type that farmers will pay a significant premium to buy by the truckload. It is a precise mixture of sand, silt, and clay. Roughly 40% sand, 40% silt, and 20% clay, balanced to drain fast enough that roots do not drown and retain enough moisture that plants do not dry out between rainfalls. It is the ideal growing medium for almost every food crop on Earth. The problem is that pure loam covers less than 10% of the planet's agricultural land. Most farms work with something less ideal and spend money and labor trying to adjust their soil closer to this ratio. A truckload of quality loam costs more than a truckload of gravel. Farmers know exactly what it is worth because they have seen the difference in yields. Peat takes approximately 1,000 years to form a single meter of depth. It is made entirely of organic material, dead plants that have been slowly compressing in waterlogged conditions for centuries without fully decomposing. The result is an extremely dark, spongy soil that holds more carbon than all the world's forests combined. Scotland and Ireland sit on deep peat bogs that have been used for fuel for centuries. When peat is burned, it releases carbon stored for thousands of years in hours. Draining a peat bog to farm it releases centuries of stored carbon in a single season. Several governments have banned the practice. Most have not. Chalk soil is made of compressed calcium carbonate, the same material as limestone, and it drains so aggressively that drought stress is a constant problem for anything growing in it. Most crops struggle, but one category of plant does not: wine grapes. The Champagne region of France sits almost entirely on chalk. So does Chablis. The English wine regions of Sussex and Kent, which have begun producing world-class sparkling wine, sit on the same chalk deposits that connect under the English Channel to the Champagne region of France. Sommeliers can taste chalk in wine. They call it minerality. Farmers growing anything other than wine grapes on chalk spend most of their effort trying to hold water in soil that wants to release it immediately. Salt kills almost everything. Saline soil has a salt concentration high enough that most plant roots cannot draw water out of it. Scientists call this physiological drought. A plant surrounded by moisture that still dies of thirst. 20% of the world's irrigated farmland is already affected by salinization, and the number is rising. When irrigation water evaporates, it leaves its dissolved salts behind. Do this for enough seasons, and productive farmland becomes sterile white crust. The ancient city of in Mesopotamia was likely abandoned in part because centuries of irrigation had salinated the surrounding farmland beyond recovery. A food crisis caused by salt is slower than one caused by drought. It is also much harder to reverse. Alluvial soil is deposited by rivers, and it feeds more people than any other soil type on Earth. The Ganges Plain in India, the Nile Delta in Egypt, the Mississippi Delta in the United States, and the Yangtze River Basin in China are all built on alluvial deposits, and together they feed several billion people. Every flood leaves a thin layer of mineral-rich sediment from upstream geology, mountains, distant bedrock, weathered rock from hundreds of kilometers away. The Nile flood before the Aswan Dam deposited sediment from the Ethiopian highlands every single year. Egypt now imports most of the synthetic fertilizer it uses to replace what the dam stopped delivering. Rivers were moving nutrients to farms for millions of years before agriculture existed. Humans built their first cities on the soil rivers left behind. 8 soil types, each one shaped by millions of years of geology, water, temperature, and organic matter. Every farm on Earth is working with one or several of these. And the difference between a record harvest and a failed crop often comes down to understanding which one you are standing on.